Hello, today we'll get started with Ngspice by taking the example of NMOS input and output characteristics. Today we'll be learning about DC sweep and nested DC sweep, like how DC sweep to be done in Ngspice. So here we can see the circuit diagram of NMOS transistor. Here the components we have is the only MOSFET M1, which is NMOS, and we have two voltage sources VGS and VDS. Here VGS is the gate to source voltage and VDS is drain to source voltage. Basically, I'll be using Linux terminal. So here is the Linux terminal. You need to get installed Linux terminal. Basically, I downloaded WSL and in which I am doing this netlist analysis. So I'll be doing this analysis in 250 nanometer technology, which is given by TSMC. So first we'll take a glance on what is model file. Okay, so I am opening this model file. Yeah, okay, we can see that here TSMC 250 nanometer technology model file. We have two models, NMOS and PMOS. NMOS is named as CMOS N and PMOS is named as CMOS P. And here we have the list of parameters which defines the transistor behavior. Like example, TOX, thickness of the oxide, and VTO is the threshold voltage, and so on like that. And here we have junction capacitances and sidewall capacitances. Okay. Yeah, while writing netlist, we will be using the names of NMOS as CMOS N and name of PMOS as CMOS P. Okay, let's get started with writing the netlist. So I'll be getting back. So I am creating the first file example as nmos.txt. We can use .txt extension or .cir extension. Both will work fine. Yeah. Here is the nmos.txt file got created. So in this we have to write the netlist. Here the first line in Ngspice is commented itself. Whether you comment deliberately or without commenting, the first line is always comment. So we will be using first line to define the whatever our headings will be there or projects what we are performing. Those will be writing in the first line. If you want to give comments in the other lines, for example, in the third or fourth line, you will be using at the rest mark like this. In the first line, there is no need of using asterisk mark. So first we'll be naming our project or this experiment as NMOS input and output characteristics. So yeah, first it will be easy for the user to understand that for what we have written the code. Yeah, here we writing the code for NMOS input and output characteristics. So there will be certain steps we need to follow in order to get our error-free netlist. So we need first thing is we need to include model file, but that is we are telling Ngspice that whatever the MOSFETs or transistor we are using here, that to be linked from the particular model file. So here I link include the model file which we have seen from TSMC 250 nanometer technology. So I am including here the model file. Yeah, after including the model file, we need to define what and all the voltage sources is there, or we can define the what and all components are there. So what method I follow is first I'll be including the model file, then after that I'll be defining the voltage sources. For example, here we have two voltage sources, VGS and VDS. So I'll be defining the two voltage sources, VGS and VDS, and later on I'll be defining the MOSFET M1, and after defining these parameters, what is asked in the question, we will be performing that analysis. Okay, first we need to define the voltage sources. So I'll define two voltage sources, VGS. Yeah, the thing is for defining voltage sources, the letters should start with V, where we are telling Ngspice that I am defining a voltage source. Its name is VGS. Here we have defined, and it should be connected between two nodes. So we'll be defining two nodes since it is VGS. Let us define gate as the one node and source is another node, which is to be grounded in NMOS input and output characteristics. We can see from the graph that VGS is connected between gate to source, which is grounded. So here we will define gate to ground, and later we have to define some value. So we will be giving DC 5 volt we will give. Okay. After defining VGS, we need to define VDD. So we will define VDD, VDS or VDD or VDS. The VDS. Okay. VDS is connected between drain to ground. Yeah. Here we will write drain as the one node and ground as the other node. Here for VDS also we'll give as DC 5 volt. After defining these two voltage sources, we need to define what and all components are there. Here we have component only MOSFET and MOS, which is to be given name as M1. And if at all resistors, capacitor, all those stuff is there, we can define in the similar way, which we will discuss in the upcoming lectures. So now let us define the MOSFET. First, we need to give the name of the MOSFET. I am here giving as M1. The important thing is the syntax for defining a MOSFET, whether it is NMOS or PMOS. We have to write the name first and the four nodes: drain, gate, source, and bulk. It is the order, it is to be followed strictly. There should be no interchanging. So first we need to connect to drain. Drain we have defined the node as drain itself. So we will write drain. Gate we have defined as gate itself. So we have to define gate. And later on source and bulk. Source is grounded, so we will write 0, and bulk is also grounded, so we will write 0. And after writing all these things, in model file we saw that NMOS is given as CMOS N, so we need to write its name. We are telling in this price that M1 is CMOS N. Therefore, now we need to give width of the MOSFET and length of the MOSFET. Basically, we are sizing the MOSFET. Now let us take width as 2 micron and length equal to 0.25 micron. You can choose anything your wish. Here I am choosing width equal to 2 micron and length equal to 0.25 micron. And after this, what we need to perform, which analysis we need to perform is to be defined. Now, first we'll be doing DC analysis. So the syntax is dot DC. We are telling Ngspice to perform DC analysis. First, we'll plot input characteristics that which means ID versus VGS. So we need to sweep VGS. So we'll be performing DC analysis on voltage source VGS. From where to where we need to perform, it's next to be defined. So we perform from 0 to 5 volt in the steps of 1 millivolt. The syntax is dot DC, the voltage source, and then the start value, and then the end value, and then in which steps we need to increase. After performing this analysis, the next thing is we need to plot the things, right? So which is to be written in control block. So what is control block? The block where we will be writing which things to be plotted or what to be done. Yeah, so we will write control block. It is very important to remember this block every time we will be using. Yeah, dot control run dot nc dot end. This is the control block which you always need to remember. What we need to plot I versus V, right? So we are telling in this Ngspice to plot I of I versus V. This is the syntax. I from which we need I from which voltage source we need VGS. Sorry, we need from VDS. Here I of some voltage source and voltage of which node we want is to be written in the bracket. So we want from gate. Yeah, I versus ID versus VGS we want, right? So the thing here to remember is whenever in Ngspice, always current is measured from voltage sources. What Ngspice is modeled is it will be giving current from positive terminal of the drain VDS to negative terminal here. When you see voltage source VDS, it will be giving current flowing from positive terminal to negative terminal like this. But what we want is we want current flowing from positive terminal into the drain. So it is reverse of what Ngspice modeled. So we will be using minus sign here. Minus I of VDS versus V of gate. This is the thing. Yeah, the syntax is I of the voltage source versus voltage of which node you want. Yeah, now I'll save. Now I'll run. For running, we need to write ngspice file name.txt. Yeah, here you got ngspice input and output characteristics. Here you can see ID is on y-axis and voltage of gate is on x-axis. So what I want to do is I want to show here ID and I want to show here VGS. So what we'll do is we'll label the things. So how to label the things? After writing this plot block, what we'll do is we will tell ngspice x label on x-axis. I want it to show VGS and on y-axis y label I want to show as ID. Now we will see how nicely ID and VGS will appear on x and y axis. Yeah, see here ID is appeared on y axis and VGS is appeared on x axis. Now I'll open. Now what I want now we plotted input characteristics. Now I want to plot output characteristics. So what I want is ID versus VDS. So this block we will be erasing. Here we will keep VGS constant and we will sweep VDS from 0 to 5 volt. Yeah, instead of VGS, we are sweeping VDS. So what you have to plot is plot of in the same current is ID same. So I of VDS. Why I am using minus sign? What Ngspice's model is? It will be giving current from positive terminal to negative terminal. But what we are getting here current is it is flowing from positive terminal to drain terminal and then returning to negative terminal. So we are modeling as minus I of VDS and versus voltage at drain this time we want, not gate. Okay. Here in the same way we will do X label as VDS and Y label as ID. Yeah, the thing is done. We'll save and we'll run one more time. See, here we got ID versus VDS. See, here it is getting saturated. Yeah. Now what I want is I want to plot this multiple times. Means this is for particular VGS equal to 5 volt. But what I want is VGS equal to 4 volt, VGS equal to 3 volt, VGS equal to 1 volt like that. I want to plot ID versus VDS for different VGS. So what we have to do is we have to do nested DC analysis. Till now we have done only DC analysis. Now we need to do nested DC analysis. The thing is simple. After writing this step, what you have to do? This is for only particular VGS equal to 5 volt. Here you can see VGS equal to 5 volt is fixed. Here VDS we have wrote 5, but here it want to sweep. We told Ngspice to sweep, so VDS will be moving from 0 to 5 volt, where VGS is constant, which is 5 volt. Now, what we are telling after performing sweeping VDS, now we are telling Ngspice to sweep VGS also. Now, for what we want, now for which VGS we want VGS equal to 1 volt, 2 volt, 3 volt, so on like that we want in the steps of 1. So we'll sweep VGS from 0 to 5 volt in the steps of 1. It's done, right? So what we have done in nested DC analysis, first we wrote the first voltage source VDS and we have swept according to the conditions we want. And later on, we are sweeping VGS also from 0 to 5 volt in the steps of 1. It's like nested for loop. For each VGS, we are performing VDS from 0 to 5 volt. It's the meaning. So now we'll save this and run. The entire like plot and all those stuff is same. So we'll save and run it. Yeah, you can see for different VGS, we got ID versus VDS. Here VGS equal to 0, 1, 2, 3, 4, 5 like that. Yeah, it's done. Now what you have to do? Uh, I need to perform ID versus VGS for different VGS. So what I'll do is dot DC ID versus VGS, right? So first voltage source with respect to VGS. So I'll write ID versus VGS for different VGS, right? So VDS will be gone here. Now here plot things, plot I of VDS versus V of, here we have to do gate. And here labeling, yeah, X label should be VGS, which we want to show for better appearance, and Y label is for ID. Now I'll save and I'll run. Yeah, you can see for different VGS, sorry, for different VDS, I got ID versus VGS. Now what I want is, instead of ID versus VGS, I want both ID versus VGS in one plot, and I want another plot in the side by side ID versus VDS for different VGS. So what we'll do is we'll perform analysis in step by step. This time what we'll do in control block we'll write. We can write DC analysis here or in control block. The thing in control block is no need to write dot .dc. If you write dot .dc and perform analysis in control block, you will get error. It will be showing no such command available in Ngspice. So what you have to do is you should remove dot command. If you do directly DC in control block, we'll be getting output. Once check. Yeah, now we got the output, you can see here. So now we'll do this. Yeah, after performing this, we'll be telling Ngspice to perform. After performing this, we'll be telling Ngspice to perform VDS for ID versus VDS for different VGS step by step. So ID versus VDS in the steps of VGS, right? So here, yeah, I of VDS is fine, and here we have to plot V of drain, and X label will be VDS and Y label will be ID. Yeah, it's the same. So what we are doing is in a control block, it will be following sequentially. So first we are doing DC analysis by sweeping VGS first, then VDS. So here we'll be getting ID versus VGS for different VDS, and then we plotted the things. And here we are doing ID versus VDS for different VGS. So here we'll be getting output analysis. Yeah, we are done. We'll save and we'll run once and we'll check. See, here we got the two blocks. Here we got ID versus VGS, and here we got as ID versus VDS. Yeah, done. So we'll revise the things. So what we done is first line is comment. So we'll use it to define the title. So so that user can easily read that and understand for what we have written this netlist. And then without forgetting, we'll be including the model file. So the syntax is dot include the file name dot txt or anything. And then what I follow is voltage sources, defining voltage sources, and then defining the components. Or else you can follow defining components and defining the voltage source, both are same. Then I defined the voltage sources. Syntax for defining voltage sources is it should start with letter V, and after writing its name, it should be connected between two nodes, positive node and negative node. So I have given it as gate to ground, and VDS from drain to 0. And first I am keeping as DC 5 volt. Yeah. After that, I defined the MOSFET. For defining MOSFET, the syntax is first we should give the name, and then after we need to connect it to four nodes in the order drain, gate, source, and bulk. Here drain and gate I defined as the same nodes, and source and bulk I have grounded. So I have given as 00, and then I linked it with CMOS and means we are linking it with model file. Which name is given in model file, we are linking in that, and then I have sized the MOSFET for W equal to 2 microns and L equal to 0.25 micron. So write in control block, the syntax is dot control, then run, and ending will be dot nc dot end. In between these blocks, we need to write the things which we need to plot or what we need to perform needs to be written in the control block. Okay, all right for today. And in upcoming lectures, we'll be seeing how to perform transient analysis and all those stuff